Hello everyone, I'm Sebastian, and welcome to the MATLAB and Simulink robotics arena. In this video, we'll talk about deploying algorithms to the robot operating system, or ROS. And here with me I've got Pulkit. Why don't you introduce yourself?
Hi, I'm Pulkit Kapur. I'm the Robotics Industry Manager at MathWorks.
Awesome, thank you. So in this video, Pulkit and I will talk about some workflows to get algorithms that you might have made in MATLAB and or Simulink out to be standalone. As far as our agenda, this is the third of a three-part series. The first two videos talked about getting started with ROS and MATLAB and Simulink respectively, and that talked about some desktop prototyping workflows. Again, in this video, we'll focus on the standalone deployment. First, we'll view the workflows possible for that. We'll talk about how to generate and how to use ROS nodes that have been generated from MATLAB and Simulink. And we'll tie this together with our object tracking example, as well as summarize our key takeaways. Let's start first with the algorithm deployment workflows. There are two workflows that we're going to present to you here. The first one is what I would call the more traditional approach. If you're familiar with the coder products like MATLAB Coder, Simulink Coder, and Embedded Coder, you might be aware that from either MATLAB code or Simulink models, you are actually able to generate C or C++ code that you can then use standalone. As you also know, ROS has a very strong C++ library. So once you have standalone code that's generated from MATLAB and Simulink, you could always manually schedule it by writing your own main file in C++ that would call these standalone functions.
Can we automate these workflows using our ROS connection through the Robotics System Toolbox?
That's right. You absolutely can. So if you recall from the Simulink video that Simulink has blocks that can perform certain ROS tasks like subscribing or publishing, and those are also supported for code generation.
Right?
So by combining the coder products with Robotics System Toolbox, you can actually go from a Simulink model all the way to a standalone ROS node. In other words, compared to the first approach we showed, this will also automate the process of generating that main file and figuring out the scheduling for everything within that model.
So that's great for Simulink, but what about MATLAB?
So recall also that there is a MATLAB function block, and that lets you call MATLAB code from Simulink models. So whether you have MATLAB code as part of your whole Simulink model, or it's just MATLAB code that you're wrapping in a Simulink model with all the subscribe and publish, you can certainly do that. Regardless of whether you're doing the first or the second approach, the same limitations for what is possible to generate code from in MATLAB and Simulink stand.
I see.
So in this video, we're really going to focus on the workflow on the right because that's the one that's more automated and has some cool features that we want to show you. Let's talk about how this works in the tool. So you start with a Simulink model, and the entire process that is automated is as follows. So the first thing that happens is you generate the C and C++ code, and then this code gets packaged up into an archive. So at this point, you have a portable file that you can transfer over to your ROS-enabled machine. Recall that Simulink and the Robotics System Toolbox can exist on Windows, Mac, or Linux, right? So by generating this archive, it gives you something that you can then compile on your own on your Linux machine, say that is running ROS. So at this point, if you have a network connection to whatever target machine or robot you're trying to put these nodes on, this transfer process can be automated. So whatever files are generated get copied over to the Catkin workspace on your machine. And for those unfamiliar, that this is the location basically where you put in all your ROS packages and ROS nodes. And once that code is extracted, you compile it with the Catkin make utility, which is also an advantage you get from using that toolchain. And once you have that node, well, it's a standalone node that you can run right on your robot or your simulator. Okay, so what we'll do here is actually go right to a part of our software demonstration where we'll show you how to generate code from our object tracking example from the previous videos. Okay, so I'm going to open an example that we've also seen in the previous video, which is our Simulink model that can talk to the Gazebo simulator. And what I'll do is show you how to set this up for code generation. What I'll do first is I'm going to comment out all the blocks that have to do with visualization, because if I'm deploying a standalone node, I just don't want to include all this visualization code right in here. So assuming that your model is, using all MATLAB code and Simulink features that are compatible for code generation, the next step is to set up this model for that. So what I'm going to do is go to my model configuration parameters. And in particular, if I go to the hardware implementation section, you see that if you have the Robotics System Toolbox, one of the available hardware boards, it's not really a board, but you get the point, is Robot Operating System. And when I select this, it will change some of the configuration parameters of my model to make sure that the model is ready for code generation.
So I've selected the hardware board as ROS, but how do I get it to my actual robot running ROS?
Yeah, so in the options below, you can actually expand them and take a look at some of the options to get to your robot or your simulator. So if I go to the device parameters really quickly, if I go to the edit option, here's where I can enter, for example, the IP address, my super user credentials, as well as the location and ROS distribution of my Catkin workspace. And you can actually test whether you are connected just to make sure before I generate code that I can, ping the machine that I'm targeting, testing my super user privileges, so on. So it seems like everything passed, and I should be able to transfer and generate code all the way to my target.
You did mention that this process was automated all the way to running on the robot. We're only building it, so where's the running part?
Yeah, so it's just in the section below. You go to the build options, and you actually have a couple of options for where you want to stop in that automated process. If you want to stop at just the archived C code, then you say none, and then it's up to you to manually transfer the code over. This can be useful depending on what your workflow is. Then you can also just build the executable node and load it, but not run it. Or you can automate the whole thing where, once I generate code from this model, it'll actually kick off the execution of the node as well. And that's what we're going to do right now. We're going to do a build and run. Yeah, once all of that is set, I'm going to go ahead and hit my deploy to hardware button. And this might take a little while to generate code from all my artifacts, but you'll see in the diagnostic viewer here that the progress of code generation will show up. And we'll be speeding this up through the magic of video editing.
And you can also generate this for ROS targets such as low-cost hardware boards such as Raspberry Pi and Arduino.
That's right. So I didn't show this, but in that hardware implementation pane, if you install the support packages for what you just mentioned, like Raspberry Pi, Arduino, so on, it's the same code generation workflow. So if you're interested in targeting hardware, we can always connect you with resources. Okay, so at this point, you'll see that code generation completed, and I got this code generation report that came up. It's an option that I set. I just wanted to quickly run through it and show you that this is the C++ code that actually gets generated from my model. And you can see there's quite a lot going on here. But one of the cool things is that as you're scrolling through this code, I could actually have hyperlinks. So I could select something here from my model, and it would point to the section in my Simulink model that this refers to. So there is that code to model traceability that gets thrown in the comments, which is really nice. So let me go over to my simulator here.
So how do we know that the code is actually running on the robot in your simulator?
Yeah, it's a good question. One thing I could do is I could move, if you remember the object tracking example, if I move this around, the robot should be running, which is great. That's one way to validate that it worked. But, that's probably not the best way to find out if something is running, right? So that really begs the question, if we have a standalone node running, what do we do with it to interact with it moving forward? So there's actually a couple of ways that you can work with the generated ROS node once it's there. The first thing is what's known as a ROS device object. So when you have a standalone node running, you can actually use MATLAB to start and stop existing nodes, and you can also verify which nodes are available. And these are the ones that you've generated code from in the past. So that's one lightweight way of interfacing with your nodes. The second thing is a functionality called external mode, which actually lets you use your Simulink model still as a block diagram and actually acts as an interface to the generated node. So you can still do all the graphical things that you could in Simulink, like be able to visualize data or change parameters. However, what's running under the hood is the generated code. So that's an awesome debugging tool. Though it does bring some overhead because of that TCP/IP interface. And the third thing is to just plainly use ROS to communicate with your generated node, right? If you set up your model to either send or receive ROS messages, or maybe use the ROS parameter server so you can modify values or extract values, at that point you could communicate with your standalone node, whether it be from MATLAB, from a Simulink model, or even just from your regular terminal. Why don't we look at some of those back in our example? All right, so the first thing we talked about was the ROS device object. So to do that, I'm just going to quickly create a ROS device, and it should read off of what's already been used. So in this case, it's already picked up the IP address and credentials for my virtual machine. And then what I can do, you'll notice that there is an available nodes option, which will show me all the nodes that are there right now that I've generated from MATLAB and Simulink. You see that I've got 9 of them there. So I can print them out. I can do r.available_nodes, and it should show me the names of all the models. I know the name of my model, so I'm just going to quickly check if my generated node is running on my device object using the name of the model. And in this case, you see that it's returning true because it is running. Then I can actually stop the node directly from MATLAB. So again, and if I stop the node and I try to, say I go back and try to move the object in Gazebo, then the robot's not responding to it because the node is not running. And I can verify that by just retyping that. And you see that now it's returning a logical 0 or a false.
This is great that you can start and stop a node and find out if it's running, but can you actually debug the model through MATLAB?
Yeah, in this case, we don't really have any debugging infrastructure, right? What we would want to do in this case then is maybe use one of the other functionality, for example, external mode. So I'm going to open up a variant of the model that we just did that would run with external mode. The only difference that I've implemented here is that now I actually have these 2 sliders that I've highlighted, and they're able to control the linear and angular velocity gains of my controller. To set up something for external mode, by the way, all you do is hit this drop-down menu for the simulation mode, and instead of using normal, you can set up external mode. And then I will hit run. And you see, once I run the model, it's actually going to go through the code generation process. As you see here, it's going to kick off the build procedure. So let's speed this up again. Okay, so our model is now running, and let me actually move this away. So you can see, well, if I again go to Gazebo and move my object, the robot should be tracking it. You see that it's moving towards the object. I move it away. But now I have utilities to debug things or verify things while I'm in Simulink. So let's drag some of this around. Well, now that I have these sliders, I can, for example, change some of my control gains. For instance, I'm going to turn up my angular velocity gain to a much higher value. And then if I move this box, I can create some instability in the robot. You see that now it's doing some crazy turning as it tries to regulate itself. And I can continue messing with that. And if I then regulate my angular velocity gain to a good value, it should settle down and have less oscillations.
So it looks like this is great for parameter tuning.
Yep, it is. And you can also do visualizations. So if sometimes if you have some data in your model that you want to visualize, you could have, for example, put a scope in here. You could have also set up logging so that you could have an entire run of your code running standalone, and then you could grab that log data at the end for post-processing.
This is pretty cool that you can debug using external mode, but I remember you said that there is a lot of overhead to running this in Simulink. So is there a way to run this standalone?
Yeah. So the last option that we discussed in the presentation was using ROS to talk to our model, right? So I'm going to open up a model that, in this case, instead of setting the gains through Simulink and external mode, I'm going to be using the ROS parameter server. You see I've got these two blocks at the bottom left of the model, which are setting up ROS parameters for my linear and angular gains. I've already generated code from this model, so I'm going to use my ROS device and I'm going to use run node to run this pre-made model. And you'll see that this should be up and running. And my robot should be tracking the object. So let me move this box around. You see that it's running. What I can do now is I can either use MATLAB, so I can say ROS param set gains.angular, and I could set that value to, like before, a bigger gain. And if I do this, then my parameter should be updated and I will introduce instability into the model. Of course, I could always get the value of my gain as well to see what it is, and I could modify that accordingly. But we don't have to have MATLAB open. So if I take this a step further, right, if we go to our virtual machine, I can open up a Linux terminal and I can do the same here. So I can now get the value of my angular gain and I can further set it to, maybe even a smaller value until I reduce the instability. Now it seems to have lost the
Tracking ability.
the box. Actually, let me use a different number here. Yeah, so now it's scanning for the object, which is good, but let me give it one real quick. And then you see it'll move away and it should not have those oscillations anymore. Now that you're running this standalone, by the way, you can use utilities like the RQT graph to verify also that the node is running directly from your target machine. So let's see that in action. If I maximize this, you'll now see that interfacing with Gazebo right here is my Simulink model generated node, which is the example model. And I also have my MATLAB global node, which exists, and this is what I was using to basically, talk to the parameter server from my MATLAB workspace. So there's a lot you can do with generating code and deploying standalone to ROS. Okay, so we'll wrap up with some quick key takeaways. As you saw with the Coder products and with Robotics System Toolbox, you can automate the whole process of generating, transferring, building, and running ROS nodes from Simulink. Or alternatively, you could generate standalone C or C++ code and call it yourself in whatever framework you might have outside of this. And then we also saw that once your node is generated, you can start and stop it from MATLAB. You can use things like external mode to communicate between the MATLAB environment and the generated code, or you could set up your model to be able to communicate via ROS messages or the parameter server once deployed standalone. So that concludes our video. As always, thank you for watching, and feel free to reach out to us via email or Facebook, and check out the other resources below. Thank you.
Thank you.